Okay, this should be the last video in this section. Solve each of the following absolute value inequalities expressed in interval notation. The minute I see absolute value and a negative number compared to a negative number, I have to think something's going on here. So what this guy is saying, the above is asking where is something that is always positive? That's the absolute value. Absolute value is always positive. Where is something that is always positive greater than a negative? Well, positives are always greater than negatives, no matter what. 2 is greater than negative 3. 22 is greater than negative 4. 976 is greater than negative 5 million. Positives are always greater than negatives. Positives are always greater than negatives. So, my answer, negative infinity to infinity, all reals. Now, note, that is different than when we are doing less than inequalities. Here was the first less than. Less than, the answer was no solution because it was asking where is something positive less than a negative. That answer is no solution. But this question is asking where is something positive greater than a negative. So you actually need to reason these out. The answer isn't always going to be no solution, or it isn't always going to be all reals. You've got to reason it out. Now again, test or quiz time. I'm not going to put one of these on there. We may or may not, depending on when you're reading these lectures in the COVID or watching these lectures. For the COVID situation that we're in fall 2020, if you're watching these in fall 21, maybe we're not in a COVID situation, so maybe there are quizzes, who knows. But if there were quizzes, I wouldn't put this on a quiz, and if there were, I would never put this on a test. But homework, anything's fair game in homework. Okay, let's do the next 2 problems, then we'll be done. Solve each of the following absolute value inequalities, express answer in interval notation. So my inequality, or my absolute value, is already known, so we just have to rewrite 2 different inequalities. The inside less than the negative number, or the inside greater than the positive number. And somehow you just have to remember it. Now, how I remember it is I think of the picture. That if I want to be greater than something and I'm thinking on the number line, I have to go away from 0. I have to go out. And so that gives me those 2 inequalities. So in this case, 5x minus 6 less than negative 19, or 5x minus 6 greater than 19. Notice again, I don't change the 5x minus 6. I know, very tempted to change that minus 6 to a plus, but we don't, because it's not just minus 6. It's the number 5x minus 6, and I don't really know what 5x minus 6 is, so I can't just change part of it. Then just solve these. Add 6. So I have 5x is less than negative 13, x less than negative 13 fifths, or add 6, 5x is greater than 25, x greater than 5, and then in interval notation, that's going to be negative infinity to negative 13 fifths with parentheses, and then 5 to infinity. Now I left a space here. Mathematically, what is correct is that or mathematically is represented by the union symbol. The union symbol means or. Now, when you come to your computer, your homework on the computer, read what they say. I've seen different things. Sometimes I've seen them use the union symbol. And if they want you to use the union symbol, that'll be down in the symbol palette when you're typing things in. Sometimes I have seen them I've seen them say, separate the intervals by a comma. Just read the instructions and do what the instructions say. And then if you're confused, you're not sure, a good trick as far as figuring out what do they really want is to click through View an Example, and the format in which they answer is the format in which you should answer. But in general, you want to stay away from your View an Example because you do need to work towards being able to do these problems on your own, all by yourself, because that's the way you have to do the problems on a test. So I'm going to go with the mathematically perfect way of a union symbol between the two of them. That's the mathematical way of saying or. Test time, I'm not going to care. Put a comma between them, put the union symbol between them, put the word or between them. I just want to see a version of the correct answer. Okay, last problem. Let's get that absolute value alone first. So I'm going to divide both sides by -3. And when I divide by -3, I reverse that inequality. So that got reversed, divided by a negative. And so I've got 4x plus 5 greater than or equal to 4. And now I rewrite 2 inside less than the negative number, or inside greater than the positive number. And so I've got 4x plus 5 less than -4, or 4x plus 5 greater than 4. And like again, somehow you just have to remember that that's the key step. And what I keep in my head is this picture, that when I want greater than, that means we're going away from things. So I need 2 inequalities going out. And that's the way I just remember it. But somehow you've got to remember it in whatever way you remember things. Then finish solving. So I'm going to subtract 5 from everybody. And I get 4x is less than -9. 4x is greater than -1. X less than -9/4. X greater than -1/4. And interval -infinity to -9/4. Less than forever is that -infinity. I do not have an or equal to, so no square brackets. Except I did have an or equal to, and I dropped it. Let's put those or equal to's in there. And that's a common little mistake that I would not take off for. The computer would completely and totally count it wrong, but I wouldn't. So I've put my or equal to's in there, I accidentally dropped it. So the less than gives me the -infinity. The or equal to gives me the square bracket. Then the or is the union symbol. And then -1/4 to infinity. And there's my interval notation. And that's the end of this section. And the end of this chapter.